Okay, so we go back to significant figures. So again, when making measurements, the number of significant figures in your measurement represent the precision. It's not accuracy, but the precision of your particular instrument. So let's take, for example, in your common ruler. So just use the side upon which you see so your ruler, and then using the centimeter scale, you should see most rulers have, well, the starting line is 0, and then you have 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then you have 1. So 1, 2, 3, 4, 5. So usually this is what you see in a ruler. So let's say, for example, in your first reading, so you get a reading that lies here, okay? And then let's say you have another reading which lies here, okay? So how would I record my measurement in this first and the second one? Well, for the first one, I can see that it is more than, if you can read, it's 0 to 1. So that means that it is subdivided into 10 equal parts. So that means that one line here, the smaller line, represent 0.1 of a centimeter. I forgot to write the centimeter. So usually ruler, again, the metric side, the inches part is for the English system, but mostly we'll be using the metric system, so don't mind about that. So for the centimeter, so every line here constitute a measurement of 0.1 of a centimeter. So how would I record my reading if I get that this one here? Well, it's more than 1.1. So I would say that my ruler reads 0.1 of a centimeter. However, it's quite obvious in the first reading that somehow it is more than 1.1. Well, here's the thing. If you're doing measurement, you can actually approximate the last portion there. Since it is more than 1.1 but less than 1.2, I can actually say that this is around 1.13. And even, or centimeters, or you can even write as 1.12 centimeter. Both are correct measurements because when you're using a ruler, the ruler can only read up to 0.1 of a centimeter. For any measurement, you can actually approximate the last one. And this is what we call the doubtful figure. The doubtful figure or the doubtful digit. And with that, that means, that's the first reading, right? So that means that if someone reads your measurement, he will take that one as, oh, he's using a measuring instrument, well, most probably a ruler that can only read 0.1 of a centimeter, okay? Because I'm gonna take that one, the last one, as your doubtful figure. That means that it's beyond. Your instrument can no longer read that particular value. Okay, so it must be for any measurement. You need to do that. So express. And for the second measurement here, are there any questions? Oops. Do we have to be exact, precise, or are we able to round? Well, just make sure, especially for a ruler, for example, because anyway, mostly we're using a ruler. So that means that if this is the case here, if you can read, if your instrument can read at a certain level of your, let's say in this case, you can read up to 0.1 of a centimeter, that means that is 1/10 of a centimeter. So therefore, in your final measurement, or when you try to record your measurement, you have to indicate the hundredths place. The hundredths place. You should place 0.3, or the second example will show you, let's say for example, in my view, it is exactly 1.4. So if it is 1.4, I will not just record 1.4. But if in your case, that is exactly 1.4, you place 0 centimeter. Because that gives an idea to the reader that, again, at least you are sure that it can read up to 0.4 of the centimeter part. This last part here could be just an approximated value, okay? So later on, I think we will be talking about errors also. Like you can write it down plus or minus 0.01. In this case, at least for your range, it would be plus or minus 0.01 of a centimeter. Do you think that answers your question, Matthew? Is that what you mean? Exact, precise, or are we able to round? So actually, even though if you think that that is 1.19, that is still a correct measurement. But if you say 1.2, but just make sure that if you think that it is exactly, it hits the 0.2 mark, so just put 0 at the end. Okay? So just put 0 at the end. So again, it's not wrong to whether, because again, that's part of your systematic error, like the way we try to measure things. Okay. So again, the significant digits of a figure, that's why it's not just if you're using a particular instrument, we can write 0.000. Okay. So the significant figures of your measurement tells you the precision of your instrument. Okay. So that means that even for your stopwatch, if your stopwatch can only read 0.01 second, so that means that, well, at least the last digit there is somehow your doubtful figure, especially if you are using a digital clock, for example. Okay. So if you're using a thermometer, for example, if you can only read, let's say, 1 degree of a Celsius, so that means that in your recording, when you try to record your work, especially if it's like a analog one or thermometer that is an analog, so you place 37.1, because if you see that somehow the level of mercury is maybe more than 37 but very close to 37, so that would be 37.1. And actually I will not correct you if you also place 37.2. That is still acceptable, because anyway it's very close to 37. But if it's close to 38, I think it's also good for you to approximate the last digit as closer to 38. So you will place 37.8 or 37.9. Okay. So at least the reader that knows this stuff will actually say that, oh, okay, it can read your instrument. Your measurement can only read up to 1 degree Celsius, for example. Okay. So, but the next thing here is, how do we identify a significant figure? Because usually when given a problem, usually these quantities will be given to you. Let's say, for example, for some problems, if you have noticed in most books, they will just not place 20 centimeters. Usually they will say 20.0. Sometimes you place 20.00 centimeters. And in that particular case, actually, that is to emphasize the number of significant figures in your measurement. Okay? So if you're wondering why the trouble of placing the zeros at the end? Well, 20.00 tells you it has a different significant number of significant figure with 20.000. It has a different significant number of significant figures of just 20. Okay? So in most books, or as we move along, if you have noticed, and in some cases, we actually write our quantity in scientific notation. And again, we do that one in physics or in any other sciences, especially for physical sciences. That's very specific. That is to indicate the correct number of significant figures. And again, why is it that we try to express the correct number of significant figures? And that is due to the fact that certain measurement or certain instruments can only read up to a certain value. Okay, so here's the thing on how to identify significant figures. So in our case, I'll just write for shorthand significant figures. I just use SF to denote significant figures. So it is considered that all non-zero numbers are significant. So non-zero means 1, 2, 3, 4, 5, 6, 7, 8, 9. So all of these non-zeros are significant. So if you have that number, if you can see that these numbers in your measurement, again, if we're talking about physics, usually numbers represent a measurement or quantity. And zeros are kind of tricky, so it's kind of trivial. So you have to take note. So there are four types of zeros, okay? So one is significant zero. So not all zeros are insignificant. And this particular zero are actually we call sandwich zeros. So let's say 2, 0, 1. Okay? So it is sandwiched between two non-zero numbers. So if it is sandwiched with two non-zero numbers, you're gonna count the zero in between as significant. Okay? So therefore, this is significant. This can be considered a significant figure, and as well as the last one. So therefore, if you're going to count the number of significant figures or significant digits, that is 3 significant figure. Okay? So let's say, for example, if you have another one, which is, let's say, 2001, well, this particular number here has 4 significant figures because the zeros are sandwiched, okay? And after decimal, after number, trailing decimal. So second situation is that if you have after decimal, so zeros after decimal and 0 after a number. So these are called trailing decimal. So in this particular case, these are considered. So let's say I'm just gonna use an example here: 0.08. Okay, so in this particular case, the zeros in front are insignificant, but the number 8 there is significant. So the only significant digit here is 8. So this is the significant figure. So essentially, this is 1. Excuse me. significant figure. If we have another example, if you have 0.080, maybe some of you will think that why the trouble of placing the 0 after 8? Well, the thing there, the zeros in front are insignificant, but the zeros after the non-zero number are called significant. So this would be significant figures. So therefore, in this particular case, you have two significant figures. Okay. So again, the zero in front here are insignificant, but the zero after a non-zero number is significant. Okay. So other is the insignificant zeros. So these are the leading zeros. Let's say, for example, you have 0, 0, 0, 0, 2. Well, essentially, I don't have any decimal there. So actually, you only have, this is just equivalent to 2, right? So this is just one significant figure, okay? And before decimal and after the number or trailing zeros, I think this is same thing as before. But let's say, for example, for number 200, the zeros after, I don't have any decimal point after the zeros here. So actually, this is just has one significant figures. So the significant digit is just the number 2. So the zeros here are insignificant. This is the significant figure. So if you want to express this one as the zeros there are significant, sometimes you try to write it in scientific notation, like 200. If you want to specify the correct number of significant digits, let's say, for example, I want to express it as 3 significant figures, because, for example, it can read up to, it's a certain measurement. So how would I do that? Well, is it not that sometimes in some books, you would see that even though the value is just 500 or 200 in this case, they will try to write it as 2.00 times 10 to the power of 2. Because when you try to do that, this becomes 3 significant figures. Or sometimes you would see 200 and then they will try to place a decimal after 0. That is just to indicate that I want to indicate that I have 3 significant figures. Okay. So again, in this particular case, you have to be careful with in dealing with 0. But all non-zeros are considered significant. So let's try to go over with these examples here for clarity, and then maybe before moving on to the next section, calculation with significant figures, let's try to just type in your questions, or you can also speak out after example number 3, okay? So let's say for the first one, 1.80 times 10 to the power of 2. How many significant figures would this one? Significant figures. 0.015, again, the leading zeros here are insignificant. So the significant is just the 1 and the 5. So 2 significant figure. And then you have 1.01. Again, you have in between 2 non-zero digit, even though you have a decimal point there. So therefore, you're going to count the 0 as significant. So this is 3 significant figures. And then 710 meters per second. So the zeros after a non-zero without a decimal, there, the 0 here is considered insignificant. So therefore, you only have two significant figures. And then the last one here, the zeros in front, again, you don't have any non-zero in front here. So all the zeros here are insignificant. So the significant figures are just your 2, 5, and 8. So you have three significant figures. So before we proceed with the next one, are there any questions? You can type. Yes.
For the 710, why is the 0 not significant again?
Can I go 700?
Yeah, that's
710?
Yeah.
Yeah. The 0 here is not significant because any 0 that after a non-zero are considered insignificant. Actually, in some other books, they say it's trivial. It could be significant or not significant. But we just follow that any 0 after a non-zero, and then you don't have any decimal following it, that would be a significant. Yep.
Okay, cool.
You might read, I know, some books, sometimes they try to make this one as, yeah. That's why it's the zeros are trivial or tricky. Okay.
Yeah.
But we just follow that one. Okay. But if you have a 0 after a non-zero, and then you don't have a specific decimal point, we will not consider that one as significant. Okay. Any other questions? None. Okay, if there's none, we can proceed with, there are certain rules also to follow when we try to operate or add, subtract, multiply, or divide significant figures. And mind you, yeah, as much as possible, you try to follow this rule. Because moving forward, if you're taking Physics 12, and most likely your teacher is Mr. Su, I think he is trying to apply these rules here. Like if you're adding measurements, again, measurements contains certain amount of significant figures. So you need to follow them, these rules here. Like if you're gonna multiply, or yeah, let's start with multiplying and dividing. So that means that if you're multiplying and dividing, again, these are quantities. You need to round off your answer to the lowest number of significant figures in the initial numbers. These initial numbers are also given. Usually, if it is a word problem, this is the given. And the thing is, you're gonna base, your final answer should be based on the correct number of significant digits or figures using this rule here, based on the given quantities. Like the given, like the height of a certain object is 30.0 centimeters, and then taking the time of 1.000 seconds. So you have to base the rules here from the given quantities. Okay, so for multiplication and division, so you follow the same rule. You try to express your final answer to the lowest number of significant figures. So that's the thing. But if you're adding or subtracting, well, in most cases, especially for formulas in physics, if you observe, most formula are in multiplication or division operation. I think you can rarely find with addition or subtraction. But anyway, if you're adding and subtracting, you will follow this rule here. So you need to round to the lowest number of decimal places from the initial numbers. Again, when we say initial numbers, these are your given. Okay, so let's try to apply this one here. So for the first one, it's multiplication, 4.56 times 2.705. It could be any quantity. Okay. So first things first is try to identify the number of significant digits. So for the first number, you have 3 significant figures. The other one is 4 significant figures. So when you try to multiply this one up, you try to write the answer first. Everything. 12.334.8. If you're gonna write the product, the whole product will give you a total of 6 significant figures. However, since you are multiplying, you need to follow the lowest number, so which is 3. So therefore, you will only record up to 3. So not 3 decimal place, okay? But 3 significant digits. And the 3 significant digits, obviously, you're going to start from left value to the right. That means that here you have tens, ones, and then you have tenths. So you're going to cut off up to 3. So 3, this is where you apply your rounding off numbers. So you're going to round it off up to tenths here. So the general rule is that if the number after that is 5 or greater than 5, we're going to round up. But if not, round down. So in this case, after, again, we cut off up to tenths, because tenths gives me 3 significant figures. So now I'll be rounding off up to tenths. Tenths of something. It could be tenths of a centimeter, tenths of a kilogram, or tenths of a second. So since after that is 3, so instead of 12.33, I will place 12.3. So that's my final answer. My final answer should follow the least number of significant figures. Okay. And then the next example is division. So just do this one in your calculator. But again, I told you that take note of the number of significant figures. The first one has 3 significant figures. And then this one here has 2 significant figures. So therefore, my final answer should take the 2 significant figures. But I will try to divide that one first. 1.98 divided by 0.45. The answer is, well, actually also in 2 significant digits, which is 4.4. So I'm going to stop. My final answer should have 2 significant figures, okay? Because I'm dividing, again, division and multiplication follow the same rule, okay? However, if you're adding and subtracting, you have to count the lowest. Actually, you're going to base it from the precision of your measurement. So the precision, again, can be seen from the number of decimal places in your number. So that means that 3.15 here, for the last number here is your doubtful figure. So you're using a particular instrument, maybe they can read up to tenths of something. It could be, again, this could represent any quantities here. But if you're adding the 2, the reason for that is the final measurement, if this is a measurement or something, the final measurement will not be more accurate compared to the least precise instrument that you're using. So in this case, you have 3 significant figures. Again, its precision is only up to tenths of something. But this one here, this is more precise measurement in the sense that you have more decimal places. That means that it can read up to tens, hundreds, thousands of something. It could be thousands of a centimeter. So for sure, this is not an if you're talking about a ruler, so this could not be an ordinary ruler. You have 2, 4, 5, 5 significant figures. However, if you are adding or subtracting, you're just cutting off. So therefore, you just have to cut off up to here. Oops. Yeah. You just have to take note of up to here. That means that when you try to add, well, try to add all the values. That's 4, that's 1, 0, 1, carry 1, 1, 2, that's 6. Decimal place will not change. That would be 5, okay? So the final answer is not 5.6014, but the final answer should be written up to hundreds. So that should be 5.60. So it's not up to the number of significant digits, okay? Again, for addition and subtraction, you try to cut off to the least precise measurement. Again, the number of decimal places. And for subtraction, same thing. If I'm gonna subtract this one manually, this is then so 9. It should be 8 point, and then this should be 5, and then 2. So if you're gonna subtract that one, your calculator will give you 25.89. However, again, you're subtracting, so you follow the rule. The second rule, which is to cut off to the least number of decimal place. And you have only to express this one up to 1 decimal place. So therefore, you're going to cut off up to here. So you're going to record this one as 25 point. Well, after 8 is 9. That is greater or equal to greater than 5. So therefore, you're going to round up. So the final answer is 25.9. Okay. So how about dealing with scientific notation here? Well, actually, you can just try. It follows the same rule. Okay. So you need to count the number of significant digits. Again, the number of significant digits in your scientific notation is only based from the value of m. So you will not mind about this. You mind about the value of m. So this one here, 3.0, that's 2 significant figures. And then this one here, 2.78, is 3 significant figures also. So if you're gonna multiply this in your calculator, like anyway, your calculator has an option of to express it in scientific notation. It will give you maybe some calculators will give you the value itself, 834. But that's not your final answer because you need to express this one to 2 significant figures because this is multiplication. So that means that I should express my final answer only up to 2 significant digits, which is up to here. So if I gonna record this one, it should be, again, in our case, the zeros are insignificant. So therefore, I can write that one as 830. It could be any unit. Or, again, just to specify the number of significant digits, I can also write this in scientific notation form as 8.3 times 10 to the power of 2. Okay? So both answers are okay because both answers have 2 significant digits. Again, this has 2 significant figures. I keep saying digits, but anyway, some books uses significant digits. Some books uses significant figures, but yeah. Okay, and then lastly here, you have 0.0050. So again, you have 0, but this is a different case with 710 earlier. You have decimal in front here. And after a non-zero, the 0 here is considered as significant. So therefore, the first number has 2 significant figures. This one has 3. And if you're gonna divide the 2, it will actually give you 0.000157763. But then again, my final answer should contain 2 significant figures. And again, the 2 significant figures from my answer is only up to the 5. So if I gonna write this one in correct number of significant figures, I can write that one as 0.00016. Again, it's 6 because after where I gonna cut off is greater or equal to 5. 7 is greater or equal to 5. Or if you want to answer them in scientific notation, that is 1.6 times 10 to the power of -4. So both cases gives you 2 significant figures, which is what I want. Again, the final answer is in 2 significant figures. So most formula in physics are multiplication or division. So therefore, might as well familiarize this one. Maybe in some cases or at the start, be more considerate first. But as we move forward, just remember this particular rule. So you just have to, you don't have to randomly round off your answer. You're gonna base it with these rules here. It's either addition or subtraction or multiplication or division. You try to follow this rule because the numbers that we're dealing in physics are quantities, and these quantities represent something, measurement or a measurement of a particular quantity. Okay, so try to remember that.